we're going to do something to help us remember this pattern. Because if we know this pattern, we're going to use a lot of sine and cosine. Okay. If we're going to remember that, if we can remember that pattern and fast, it helps us with these so much. Okay. All right. So I want everybody to stand up. Go. On our feet. Everybody up. Everybody stand up. Let's go. Promise this is going to be good. Okay. So you haven't seen your mouth, so you can stand on a chair in front of the room yet, right? Okay. Stand up. You do it. Stand up. Everybody stand up. Let's go. Come on. Stand up. All right. So we're going to try to remember these two formulas here. Just the top two. Okay. I came up with this when my 6th grader was a baby. So I would say this to him over and over and over, and he still remembers it. And I don't know how he remembered it, but he remembers it because he did his routine in the car the other day. All right. So the way this goes is there's a little bit of a chant. Okay. So it goes sine, cosine, cosine, sine. Okay. Ready? I'm gonna say it again. Okay. Then we're all gonna say it together. Sine, cosine, cosine, sine. All right. Okay. So we're gonna say it together on the count of 3. You ready? 1, 2, 3. Sine, cosine, cosine, sine. All right. Say it again together. I want to hear everybody this time. Okay. And I'll let you sit down until we've got this down. Okay. I promise there's a fun part at the end. Okay. All right. So get on the count of 3. 1, 2, 3. Sine, cosine, cosine, sine. Okay. Now comes the other part of the chant. Okay. So this one goes cosine, cosine, sine, sine. Okay. Cosine, cosine, sine, sine. All right. You ready? On the count of 3, let's try that one. 1, 2, 3. Cosine, cosine, sine, sine. All right, we're going to do it again on the count of 3. 1, 2, 3. Cosine, cosine, sine, sine. All right. Now we're going to put the 2 together. Okay, I'm going to say it all together in one shot, right? It goes sine, cosine, cosine, sine, cosine, cosine, sine, sine. See, Cedric's got it already. Yeah. See, and he's smiling and he likes it, okay? Whoa. I'm going to make it even better for you. All right, here we go. I saw the smile. All right, here we go. I'm gonna say it one more time, okay, and then we'll do it together, right? It goes sine, cosine, cosine, sine, cosine, cosine, sine, sine. All right, so we'll do this together on the count of 3. You ready? 1, 2, 3. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. All right, we'll do it one more time on the count of 3 together, and I'm gonna add one more part, okay? All right, ready? On the count of 3. 1, 2, 3.
Sine, cosine, cosine, sine, cosine, cosine, sine, sine.
Okay, it gets better because if you just do this while you're doing it, it makes you remember it even more. Okay. No. I've done this pregnant on this chair before. Okay, so I didn't fall. All right, you ready? Okay, so I'll do it once. Okay, and then you're gonna do it with me, but I have to see all the head bobbing. Okay, or we don't get to sit down. Okay, so it goes. Sine, cosine, cosine, sine, cosine, cosine, sine, sine. All right. See? You're laughing in math class. All right. I can't point and do that because I will fall. Okay? All right. So on the count of 3, I want to see all the head bobbing to go with it. Okay? All right. Because it's fun. All right. Ready? On the count of 3. 1, 2, 3. Sine, cosine, cosine, sine. If you don't want to sit down, okay, we're going to do this again because I don't see any head bobbing. Let's go. No sitting down until there's all head bobbing. All right, you ready? Okay, Cedric, come on. Head bobbing.
Cosine, sorry. Cosine,
okay.
Cosine, sorry.
All right, on the count of 3. Yeah, just do this head bob, all right? That's all it is. My hair is going to fall out. All right, you ready? On the count of 3. 1, 2, 3. Sine,
cosine, sine, cosine, cosine, sine,
all right, Giselle, get up here. You're not head bobbing.
Let's go.
Let's go. Daisy, let's go. Up to the front, thank you. Come on, let's go, Giselle and Daisy. If you're not going to head bob, get in front of us. All right, we're all going to head bob. All right, Becky, move to the front. Daisy, come on up. All right, let's go. You ready? Okay, on the count of 3. It's not hard. You just have to do this. All right? All right, on the count of 3. 1, 2, 3. Sine, cosine, cosine, sine. I'll make you 2 do it by yourself if you don't do it. All right, let's do it again. One more time, because Giselle and Daisy haven't done it yet. Okay, you ready? Count of 3. 1, 2, 3. Sine, cosine, cosine, sine, cosine, cosine, sine, sine.
I'm not gonna
I know!
They didn't do it.
Okay, go sit down.
Wait,
Go sit down.
A wants to go.
What's wrong?
A wants to go.
No, nobody else has to stand up here. Okay, that's going to help us remember this and do these problems a lot faster. Okay? So we don't have to keep looking up the formula. We can just do the chant. Okay? All right. Let's do this. Okay. So we have example 1 there. Okay? And again, I pulled these problems right out of Delta Math, so it should make the homework like really manageable and easy. Okay? So it says for positive angles A and B, and notice that these are the turtle problems. Okay, so they're all the turtles today. It is known that sine of A is 12 over 13, cosine of B is 9 over 41. We need to find the value of cosine of A minus B. Okay, so I'm going to leave myself a little bit of space up here. I'm going to write it about halfway down, because there's a little bit of work I'm going to have to do, but I want you to see what work you have to do. Okay, so I'm going to write it as cosine of A minus B. Okay. All right, think back to the chant. Look at cosine. Cosine, cosine, sine, sine, right? So I do this. I'll sometimes do this to get it down, because it goes fast, right? Cosine, cosine, sine, sine, and then I go back and I write it in. Okay, and then you plop in the letters. It's A, B, A, B. And then the thing you have to remember is on cosine, you flip the sign. On sine, you keep the sign. So on cosine, it's a minus, so we're going to switch it to a plus. I did not leave kept writing up. Okay, so let's plug in what we know. We know the sine of A, okay, so I can put that into the formula, 12 over 13, okay? And the cosine of B, 9 over 41. The problem is we don't know the cosine of A and the sine of B. I have to figure those things out. But I have enough tools in my pocket to be able to figure those things out. Okay, I just have to get them out. All right. So we're going to go back to using the triangles. Okay, remember how we used the triangles a long, long time ago? Okay, it seems like a long time ago. It was probably only like a month ago. Okay, so I'm going to do my A triangle. Okay. I know the sine is opposite over hypotenuse. I'm going back to that thinking right now. So this is going to be 12 on my opposite, 13 on my hypotenuse. How do I find the missing side? Pythagorean theorem, right? Unless I know the triple, it is a triple. Okay. And for a while, these are nice triples. So I'm going to write down that is 12 squared plus, x squared equals 13 squared. What's 12 squared? 144. Good. What's 13 squared? 169. Okay. All right. 169 minus 144. 25. And I'm going to take the square root. What's the square root of that? 5. Good. Okay, so I know that my cosine of A has to be my adjacent over my hypotenuse. So I can put in 5 over 13. So that comes from right here. Okay, so I had to solve the triangle in order to figure that out. Okay. Okay, next part is I knew the cosine of B, but I don't know the sine of B. So I'm going to do the same thing. I'm going to get the triangle out. Okay. All right, cosine is adjacent over hypotenuse. So my adjacent is 9, my hypotenuse is 41. What am I going to use again? Pythagorean theorem again, right? So 9 squared plus x squared equals 41 squared. All right, 9 squared is 81. I don't know 41 squared. I got to go figure that one out, right? And it's okay when we get to this calculation here. If we're using Desmos, I'm fine with that. I'll put it on. I'll make sure it's on your quiz. Okay. So it's more about making sure you can plug in the ratios. And I'll even show you how to use the fractions in Desmos. Okay, because I want a fractional answer on these. All right, so let's see. We said we needed 41 squared, right? So 1,681. 1,681. All right. When I subtract 81, what do I get? 1,600. I got to take the square root. What's the square root of 16? 4. And then put as it's one. What's the square root of 100? 10. So there's 1 0 over. That's how I looked at it. I saw 16 and 100. So it's 40. Doesn't make sense for it to be 400, right? So it's 40. Or you put it in your calculator. Okay. All right. I need the sine of this triangle. So what's on my opposite on that triangle? 40. What's on my hypotenuse? 41. Perfect. Okay. So at this point, we've got to do a lot of fraction work. Okay. Here's what I'm going to let you get away with. Everybody open Desmos if you didn't yet. Get it open. Okay. And let's practice this in Desmos. Okay. Because a good skill is to make sure you know how to use your calculator effectively. Okay. The calculator that's on SATs and PSATs, which is your next test that's coming up, we're already thinking about that for next year. Okay. Desmos is embedded in there. You have to know how to use it well. Okay. That's also what was just in the SBAC and all of that stuff. Okay. So look in Desmos. And what we're going to do is I can't remember my numbers. It was 5 over 13. Okay, so 5, I'm going to do 5 divided by 13. I'm putting that in parentheses. Okay. And then I'm multiplying that by 9 over 41. So 9 divided by 41, closing the parentheses, and then I'm adding it to, doing another set of parentheses, 12 over 13. Okay, times 40 over 41. Now, I want your answer in a fraction. Did I get a fraction? No, so I want a fractional answer. See this little button right there? Doesn't that look like a fraction? Click it and see what happens. Wasn't that magical? I just got my fractional answer, and if I unclick it, it goes back to decimal point, okay? If you're using the standard scientific calculator, or we end up using the graphing calculators at some point, there is a function to do that as well. But you're going to have to use Desmos in a lot of your testing, so it's good to know that functionality. And it's so much easier. I mean, literally, you click that button, okay? So we're going to write down 525 out of 333. And looking at the Desmos answers, I believe that the Delta Math answers, I believe that they're in fractions. So I totally lost the number though. 525, 533. 525 over 533. Okay? So I'm going to take the fraction work out. I want you to really work hard in making sure you're getting the right fractions in there. Okay? Any questions on example 1 there? Okay. Looking at example 2, okay? Similar problem, okay? We have positive acute angles. It's known that cosine of A is 28 over 53, sine of B is 35 over 37. We're supposed to find the value of sine of A minus B, okay? All right, so the first thing I'm going to do is I'm going to write down my little sine, cosine, cosine, sine part. And then I'm going to figure out what I have and what I don't have. Okay. So I have the sine of A minus B. And you guys, notation is really important as you're going into next year. Okay. You have to write things down. Okay. You have to make sure your notation is proper. Okay. All right. Let's think back to our little chant. Okay. Sine is what? Sine, cosine, cosine, sine. And again, when I'm thinking it, I go sine, cosine, cosine, sine, right? And then I go back in and I fill it in. Because it's too much to try to write the whole trig, right? To the whole piece of trig, right? It's too much to write sine. I just write the first letter, and then I can go back and fill in. Then I plop in my letters. A, B, A, B. Or whatever the letters are that they give me. This is not there. Okay. A, B. Okay. Now with sine, we keep the sign that we started with. So keep it if it's, or actually think about this. Sine starts with the letter S, right? This is the same sign. This is change the sign. It starts with the same letter, right? So it's cosine, change the sign, sine, same sign. Okay. All right. So I'm keeping the negative. All right, let's fill in what we know. Okay. I have the cosine of A. So I can plug that in. So that's 28 over 53. I have the sine of B. So 35 over 37. So I'm missing these guys. I've got to figure out what they are. I'm going to use my triangles again. Okay. So I'm drawing my triangle. I'm going to draw my A triangle. And I'm just labeling it with an A as the angle name just because that's what we've got. Okay. All right, help me out. Cosine is what over what? Think back to SOHCAHTOA. Adjacent over hypotenuse. So adjacent is 28, hypotenuse is 53. What do I need to do to find the third side? Pythagorean theorem. So 28 squared plus x squared equals 53 squared. There was no way to make the numbers all nice because they tried to keep them triples, and the triples get really big really fast. Okay, so we're going to use Desmos. Let's go use Desmos again. And watch the shortcut I could do on Desmos. Let's try to work smart and not hard. Think about this. Aren't I going to have to take 28 squared and subtract it from 53 squared? Aren't we ultimately going to do this? 53 squared minus 28 squared. Couldn't I put that in my calculator that way right now? There's nothing that says I can't. So let's do that. Okay. So I'm going to Desmos, and I'm going to I'm trying to teach you some shortcuts too. Right? 53 squared minus 28 squared. Oops, squared. So 1,920. 1,920. What do I have to do to that 1,920? Square root it. I totally did not leave myself enough space. So x equals. So I am going to square root 1920. Oh, that did not come out pretty at all. Did I write the wrong numbers in? I put 52 instead of 53. Thank you. 53. So 2025. That's better. Maybe, hopefully you guys write down the right number. 2025. Isn't that somebody? That's not quite. That's next year's graduation year, right? All right. I know the sophomores, it's 26. So. Okay. Oh, look at that. A nice number. 45. Okay. So 45. So I know that the sine of that triangle would be 45 over 53. Okay. All right. Now we got to find the cosine of the other triangle. So I'm going to draw out my triangle for B. All right. Sine is what over what in SOHCAHTOA world? Opposite over hypotenuse. So opposite is 35. Hypotenuse is 37. That's going to be our x value. So we've got x squared plus 35 squared equals 37 squared. All right. Again, couldn't I use the same shortcut, 37 squared minus 35 squared? Yeah, let's do that. Let's not write more stuff than we, and even if you didn't write that line out, I would be okay with that. I'm going to close some stuff out here. 37 minus 35. So 37 squared. And that is kind of the nice part about Desmos is sometimes on a scientific calculator, you lose what you typed in. On Desmos, you don't. So that's really nice. Our graphings, when we get to graphings next year, we don't either. All right, I got 144. 144. How do I undo the square? Square root. What's the square root of 144? 12. So I didn't need to do that in my calculator. All right, I need adjacent over hypotenuse. So I go 12 over 37. And then at this point, I'm going to go ahead and put it into Desmos. So I want you to take a minute, try putting that into Desmos for me, okay? I'm going to kind of peek and see what I have left to do here really quick. Oh, I saved. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, Oh no, wait, do I have tangent in it? Oh no, tangent's in there. Okay, I'm going to put it in. Okay? So I totally lost it. 45, 53, 12, 37. So 45 over 53 times 12 over 37. Okay. And then we've got 28 over minus 28 over 53 over 53. And it was 35 over 37. 35 divided by 37. And then I'm going to toggle the, and it's okay if it comes out to be a negative answer. The other nice thing is it puts it in lowest terms, so I don't have to do lowest terms. So negative 440 over 1961. So negative 440 over 1961. Okay. So we've seen one sine, we've seen one cosine. Again, when you have a sine, you keep the same plus or minus in there. When we have cosine, we change it. Okay. Before we get, I'm looking at what's left here. Some of them are going to get uglier. I want you to try one on your own. I want you to try example 3. Okay. We probably skip example 4. I'm going to kind of pick and choose from here on out because I want to make sure we get through what we need to get through. So take a minute, try example 3, beginning to end on your own, see what you can do with it. Okay. Yeah.
No, you've got to figure it out on the next step. So you got to use that triangle. So find tangent and then triangle. And you go find the cosine and the cosine of that triangle.
So you guys, there's a little bit of an extra trick in there, right? You didn't have the cosine of B or the sine of B, right? But you have the tangent. So set up your triangle using the tangent. You have the opposite and the adjacent. Find the hypotenuse. That'll get you the sine and the cosine. I'm going to give you like 45 more seconds to try it, and then we'll work on it together. Okay? I threw that extra loop in there. Sorry. Okay, wherever you're at, let's look at it together. Okay, so I did the part where I did cosine, cosine, sine, sine. I dropped my A and my B in there. For cosine, did have the same sign or do we change the sign? Change it, so it's got to go minus, okay? I'm going to put in what I know, which is only, unfortunately, sine A, right? So I've got 28 over 53. All right. So that's all I can get. So I'm going to have to do some triangles. Okay, so I'm going to do my A triangle, okay, which sine is opposite over hypotenuse. So opposite is 28, hypotenuse is 53, okay? So we've got x squared plus 28 squared equals 53 squared. So I'm going to do 53 squared minus 28 squared. That seems familiar. Did we do that one already? I feel like we did, but maybe we didn't. 53 squared minus 28 squared. So we did do this one, 2025. See, they've only got so many triples in there. So x squared equals 2025. Take the square root. What do we get for x? 45? Square root 2025. 45. Okay. So I know that so now I can do the cosine. The cosine is 45 over 53. Okay. Now, I threw this extra little loop in there where it gave you tangent instead of cosine, right? Or sine. So just do the same thing, but we're going to have to, we can't write anything in yet. Tangent is opposite over adjacent. Do we know that one? It's a triple. 3, 4, what? Do I know the other number? So it's 3 squared plus 4 squared equals x squared. What's 3 squared? 9. 4 squared? 16. 25. What's the square root of 25? 5. We should know 3, 4, 5. Comes up a lot. Okay? All right, so now I'm just going to take the cosine of this triangle. Cosine would be 3 over 5. Sine would be 4 over 5. Okay? And at that point, we're going to take that and we're going to put it into our calculator, okay, or to Desmos. So 45 over 53. I'm going to close some of this out. Okay. 45 over 53 times it was 3 over 5 minus 28, 53, 4, 5. 28 over 53 times 4 over 5. Okay. All right, and then toggle it. So I got 17 over 265. Okay, yeah. This? Did I do that again? 43, it's supposed to be 45. Okay. So 23, did it recalculate? Yeah, 23 over 265. So 23 over 265. Thank you for catching. Okay. All right. I'm not going to do another one that's all the triples. Okay. So I'm going to skip over example 4. Okay. So because I want to make sure we hit a little bit of everything. So I want to do one of these ones that's harder. Okay. There's some goofy stuff that give you some with radicals. Okay. So I'm going to do example 5. Okay. And then I want to do at least one with tangent. Okay. So that way when you're working on homework, so we need to probably do at least example 8, maybe example 9. It's literally just applying the formula. Okay. But I want you to make sure you're able to do all the homework. So when I put it out there. Okay. So looking at example 5. You're given that cosine equals 17 over 5. So I know that that's adjacent and hypotenuse. Sine of y equals 2 square root of 2 over 2, which is opposite and hypotenuse. And that angles x and y are both in quadrant 1. Find the exact value. So again, it's wanting an exact value. That means no decimal points. You need a fraction or a radical. Okay, we're going to have some radical work in this one. Okay, of x, cosine x plus y. All right, so I'm going to write cosine x plus y. All right, what's my cosine pattern? What do I start with? Sine, sine. So, and I write it back in. Sine, sine. All right, we've got x. Well, I'm dropping x and y in there. And then on cosine, do I keep the sign, or do I keep, is the sign the same, or do I change it? Change it. So it's going to be negative. Okay. All right, I'm going to put in what I know. So I know cosine of x is square root of 17 over 5. The sine of y is square root of 2 over 2. All right, I'm going to use my triangles to figure out the other two. Okay, and this time I'm probably going to have to do more fraction work because it's going to have radicals in the answer. All right, so I'm doing my x triangle first. My adjacent is square root of 17. My hypotenuse is 5. I don't know. I'm going to call this A for lack of anything better right now. So I have the square root of 17 squared plus A squared equals 5 squared. It's because it had an x in the problem already. All right, square root of 17 squared 17. What's a square? What's 5 squared? 25. Good. And then I got to subtract 17, so it's 25 minus 17. What do we get? 8. I'm going to undo the square, so it's the square root of 8. I pulled these right out of Delta Math, so unfortunately there's some reducing to do there. Remember when we did can and can't do boxes? It was 4 and 2, right? 4 goes in there 2 times. So this means that that's 2 square root of 2 for that side. Okay, so that for my sine of x, I'm going to say my opposite is 2 square root of 2. My hypotenuse is 5. Okay, now I'm going to do my other triangle, which is the sine of y triangle. So I've got y. And my opposite is square root of 2. My hypotenuse is 2. This one should be familiar. So I've got square root of 2 squared plus, I don't know, a squared equals 2 squared. What's square root of 2 squared? 2. What's 2 squared? 4. I got to take that 2 and move it to the other side. What do I get? We're subtracting, right? 2. I'm going to take the square root. Hey, what do you know? It's the square root of 2. That was the 45, 45, 90-ish triangle, right? Okay. All right. This isn't square root of 2 over 2 on our unit circle, right? It all loops back together. All right. So cosine is adjacent over hypotenuse, so square root of 2 over 2. All right. The nice thing about these is the denominators are going to be the same. Okay. So what's 5 times 2? 10. So I know both my denominators are 10. Okay. If there's numbers inside a radical, you multiply them together. If it's outside a radical, you multiply those together. So 17 times 2, I believe, is the square root of 34. Okay. What's 2 square root of 2 times square root of 2? What's our shortcut? It's square root of 4, but what's square root of 4? 2. So can't I just write it as 2? Okay. All right. I'm going to make a guess at what. Go ahead. I would probably. It doesn't matter. You have an extra step if you do this. You'll have to take that square root, right? I was trying to take a shortcut. Okay. All right. I am not sure. You might have to play with it a little bit in Delta Math when you do the homework. I could put this over the same denominator of 10 and go square root of 34, and then 2 times 2 is 4. They might reduce more. I'm looking at one now. It's not the same one. I don't think they're going to reduce more, but they could have reduced this to a different fraction than what we had there. Okay. All right, let's try to get one of the tangent problems in so we make sure we've covered that today. Okay, it's just another formula. Okay. All right, I way over planned for you guys. All right, so tangent is this one. Okay. It's tangent, tangent, 1 tangent times tangent. So there's an addition on the numerator and a multiplication in the denominator. So let's take a look at example, where am I at? 7, 8. Let's look at 8. Okay, so we're looking at example 8. Okay. Yeah, put your number in there. Okay. All right, so I'm going to write it out a little bit. It's tangent, tangent, 1, tangent, tangent. Okay, so in here I have to do addition, subtraction, and we keep the sign on the top and we change the sign on the bottom. That's the pattern. And then I'm going to plop in my letters, A, B, A, B. Okay, I'm going to write in what I have. I don't know the tangent of A, but I know the tangent of B is 20 over 21. Okay. The tangent of A, I don't know again, but I know the tangent of B is 20 over 21. So I'm going to use this, find a triangle. I don't need to worry about the triangle for B, right? Just the triangle for A. That's kind of nice, right? So I'm going to do my triangle for A. So what's sine in SOHCAHTOA world? Opposite of our hypotenuse. So opposite is 7, hypotenuse is 25. We're back to nice ones without radicals, right? So I'm going to say x squared plus 7 squared equals 25 squared. And I'm just going to do 25 squared minus 7 squared in my calculator. All right, so I'm coming to my calculator. I'm going to do 25 squared minus 7 squared. Ooh, squared. 576. I think that's on our list, isn't it? No, it's not. Oh, yes, it is. It's on the list. What's 5 squared to 576? Yeah, 24. 5, 7, 6. Take the square root. I get x equals 24. Okay, so tangent would be 7 over 24. Okay. And then again, 7 over 24. I know that looks like a horrible complex fraction. Okay. Let's use the power of Desmos to help us again. Okay, so I'm letting you get away with doing a little less fraction work unless it's got the radicals in it. Okay, so let's see what we can do with that. We're going to do fractions all over the place. I know, it's our favorite math F word, right? Fractions. At least it is today. Okay, so I'm going to use parentheses in my numerator there. That's how I sometimes don't look up the little fraction thing. 7 over 24, 20 over 21. 7 divided by 24 plus 20 divided by 21. I'm going to double check to make sure I did that right. Yep. Okay. Then I'm going to hit the divide key and see how it becomes the complex fraction. And then I'm going to do 1 minus, and it's 7 over 24 times 20 over 21. And again, flip it to the fraction. So 627 over 364. And it's okay to leave it improper. 627 over 364. Just double check that I wrote that right. Yep. Okay. All right. I am going to, in the next minute or two here, I will assign a Desmos. I'm not going to do another tangent one because it's more of the same. Okay. I've shown you one. You can practice it in the homework. So look at all those examples we ended up skipping, okay? So just follow the patterns, okay? And make sure you do some practice, because hopefully we learned when we don't practice, we don't do very well in the quiz. When we do practice, we tend to do better, okay? Remember, if you need to re-quiz 8.1, 8.2, you need to come in Tuesday, Wednesday, or Thursday this week and get it done. Actually, I can't do Thursday. It has to be Tuesday or Wednesday, okay? I have to leave as soon as your class is over on Thursday because I have to fly to see my dad. He's not doing well. So I'm flying to Idaho on Thursday afternoon. So he's been in the hospital almost a month now. But it's okay. I'm going to try to get Mr. Clifton to come for you guys. All right. So you guys have the rest of the period is yours. Okay. I know that was a long, and it got less fun after I stopped bobbing my head. So I'm going to hit this stop button. I will post the homework here in the next minute, okay?